Hello everyone, this is Practical Organic Chemistry lecture, and in this lesson we shall cover about oxidation of benzoin to benzyl. So like you see, this is a continuation of the set of mechanisms that we have been doing throughout the weeks for the synthesis of hexaphenyl benzene, where we need two major inputs for that. We already finished the synthesis for diphenylacetylene, and then now we are at the process of synthesizing the tetraphenylcyclopentadienon. For today, we will look at the second mechanism for the conversion of benzoin to benzyl. So on the slide you can see the mechanism for today, or the target experiment for today focuses on synthesis of benzyl from benzoin. And in the mechanism we're going to use copper acetate as a catalyst, and what it does is copper acetate reacts with ammonium nitrate, where the ammonium nitrate reduces to ammonium nitride, whereas the copper oxidizes from copper plus to copper 2 plus. And then this copper reacts with an organic compound, the benzoin, and it oxidizes it to benzoin. So when you see here in detail, the copper abstracts an electron from the pi electrons of the benzoin and creates a radical on oxygen, and then the sulfate part of the copper acetate here, the acetate part of the copper acetate is used as the base here to abstract the hydrogen, and then the hydrogen carbon double bond will delocalize to create a newly formed double bond, and then that radical delocalizes back to carbon, and the radical all the way goes to the second carbon, and again a second mole of copper acetate comes. The copper takes the electron, creating a deficiency on carbon atom, which this carbon will become a carbocation, and then the acetate will take the hydrogen, and the hydrogen oxygen electrons will delocalize it to carbon oxygen bond, making the second carbonyl carbon, and then with that the product is formed. So in the experiment we'll be doing a reflux setup, which you'll need a condenser and a round bottom flask to do that. And before you start the reflux experiment, you can have dry clean round bottom flask first, and then add 1.75 grams of benzoin, 5 milliliters of glacial acetic acid, 8 grams of ammonium nitrate, 1 milliliter of 2% solution of cupric acid, and finally 2 boiling chips. Boiling chips actually are stones, and if you could not find stones in the lab, you can also use broken glasses, because that will help the setup from explosion. So the reflux is going to run for 1.5 hours, and during the process we expect oxidation of copper from copper 1 to copper 2, and then the solution, blue solution of copper acetate will also be converted from blue color to light green color. That's an indication for the full oxidation. And the next step is to cool the reflux to about 50 50 degrees Celsius up to 60 degrees Celsius, and then pour that solution into 10 milliliter of ice cold water with stirring, and then crystals shall be formed, and we filter those crystals using vacuum filtration, which is a cold filtration, and then we wash them with water, preferably with distilled water. And in here we need the crystals to be as dry as possible, because we need to weigh them and then calculate the yield in the end. And unless we get the accurate experimental yield, it will affect our calculation of percentage yield in the report. And yeah, nitrogen gas is evolved in the experiment because it's a sequence reaction from the reduction of the ammonium nitrate to ammonium nitrite, and as a result that ammonium nitrite also further go to nitrogen gas and water. However, it's not the purpose of this experiment to trap that gas, and you don't need to do the trapping. Also, the crystal we get from here is pure enough to do further experiment, and if you think maybe to do the recrystallization for the sake of purification, you don't need to do that in this experiment. And finally, safety issues regarding this experiment: acetic acid, even if it is weak acid, it can cause significant chemical burn to our skin and should be handled with great care. And the best way to be safe from this is to wear gloves at all times in the lab. And the acid also has a certain strong smell, and it's better if we can avoid inhaling any smell from the acid. And of course, ammonium nitrate is a very strong oxidizer, which can cause fire under certain heating, and even the solid can cause explosion if it is heated before the recommended above the recommended range. And for that we have to follow the experimental procedures here strictly, especially when working with ammonium nitrate. And any contamination with this chemical is not safe. So for that we can avoid the contact by wearing gloves at all times in the lab. And of course, as much as possible, we have to avoid inhaling the dust from ammonium nitrate, as well as from any dusts, including the product Benzil. Okay, when you collect the crystals, try to avoid any dusts that may come from the product while you collect the crystals. For further information, I recommend you to look for possible health effects of Benzil and benzoin, especially benzoin, on a DNA, and I'm sure the material safety data sheet will have some information about these chemicals, and it will help you if you revise that. Copper acetate has a long history that begins in the World War II. During this time, it was used as a shark repellent, and in fact, around 600 people who were survivors from that devastating war was killed by shark because they couldn't use, or they failed to use, the copper acetate while they were in the water or while they were in the oceans. And so copper acetate is a shark repellent. As usual, we'll do spectroscopic analysis for our samples. I hope you remember that IR does not recover samples and we need to use minimal amount of sample, whereas from NMR we can recover our samples by washing with deuterated chloroform. And then that will bring us to the end of our lecture for today. Thank you for your time. For any questions or comments, you can leave them in the YouTube channel. Hope to see you next week.